Hello students, welcome to ShirtBack Academy. In our lesson today we're going to be covering section 3.4 in the ITF Plus course. The topic for this lesson is application architecture. Let's begin. Application architecture is the process of designing models for how businesses will install and deploy applications for their authorized network users. Software architects design and analyze application projects. They create new applications, improve existing ones, develop prototypes, and update technical manuals. Architecture diagrams provide high-level graphical displays of how applications are deployed on websites, databases, and network devices. Local host architecture is the storing and running of applications on computer devices connected to a network. Local hosts use hard disk drives, SSD drives, and external storage such as USB flash to store application process files. Users access applications by logging onto the host computer and opening the application files. Local hosts do not require an internet connection to run applications. As long as computers are connected to a network domain, they can access all the files and applications stored there. Client-server architecture is a network model where each computer or process is either a client or server. Clients are workstation PCs from which users can run applications. They do not provide hard disk storage or local installations. Client workstations will typically have a monitor, keyboard, and mouse. Servers are powerful computers that manage disk drives, printers, and network traffic. They are the devices from which clients can access files, applications, and processing power. Application servers are network computers dedicated to the storage of core application process files. Cloud-hosted architecture is the storing and retrieval of application files and processes from a remote internet-based server. There are three common cloud models: software as a service, platform as a service, and infrastructure as a service. Software as a service, or SaaS, allows users to run application files over the internet that are maintained remotely. Platform as a service, or PaaS, allows user interfaces to provide access to applications and databases that are stored remotely. Infrastructure as a service, or IaaS, will remove all physical hardware devices from our network system. We will run our applications entirely virtual. Layered architecture is a client-server model that physically separates presentation, domain logic, and data access functions into distinct tiers for management. Presentation layers provide a user interface for application viewing on an image display. Business logic layers encode the rule sets for creating, storing, and modifying application data. Data access layers record all login authentications, accounting, and resource use of applications by authorized users. N-tier layering is a model that allows developers to identify their own multi-layer tiers and processes. Event-driven architecture is commonly abbreviated as EDA. It's a software model that creates, detects, and reacts to application events. Events are any change in an application's data state. Remember, the three data states are rest, transit, or use. Event producers are servers, computers, and network devices that store application data for user access and retrieval. This is an example of data at rest. Event streams are application data packets sent over a network. This is an example of data in transit or motion. Event consumers are computer devices that are actively running application files and processes. These are an example of data in use. Microkernels are the minimum necessary core application files we need to run an application. Access to microkernels are limited to administrative level users. Plugin modules are distinct standalone components that each provide processing resources that allow the application to run properly. Registries are system locations where index records are kept that identify each plugin module's application process. Microkernels are frequently used within other architectural models. Microkernel patterns work well with defining specific applications. Microservices are an architectural model that structures application files in collections of related standalone services. Microservices provide several structural advantages. Each service is independently deployable. They are interrelated application processes, and they provide fast delivery of complex applications. Microservices are popular with application developers as complex software can be created incrementally. A common example of microservices are e-commerce storefronts. Each item that's listed for sale has its own microservice that contains product and payment processes. That will conclude this lesson. In our next lesson, we will cover section 3.5, web browsers. If you have any questions about the contents of this lesson, please review the course notes and exam objectives for section 3.4. We thank you for following along to the video. We will see you in the next one. Enjoy the rest of your day, everyone.